For the first example of a sequence that we looked at with terms 5, 10, 15, 20, 25, etc., we noticed that the individual terms were all multiples of 5, and that was the pattern that we saw. However, you may have seen a different pattern, noting that to get from one term to the next, we have to add 5. 5 plus 5 gives us 10, 10 plus 5 gives us 15, 15 plus 5 gives us 20, etc. In this case, we can say that a term can be calculated by taking the previous term and adding 5. So specifically, a sub n comes from the previous term, a sub n minus 1, and then adding 5 to it. However, when we do something like this, we also need a starting term, and so we would also say, and a sub 1 equals 5. We have a name for defining a sequence like this. We call this a recursive formula, and we can define sequences with a recursive formula so long as we have a first term and then a formula that tells us how to get subsequent terms. So if we had a formula that was defined like this, a sub n equals a sub n minus 1 plus 5, and a sub 1 equals 5. Well, we're given the first term, a sub 1 equals 5, and then we can use this formula to find the rest of the terms. So a sub 2, we're told that we can get a sub 2 by taking a sub 1 plus 5. And since we know what a sub 1 is, we can substitute that in, and we get 5 plus 5, which gives us 10. And then for a sub 3, we can take a sub 2 and add 5 to that. We know a sub 2 is 10, so that gives us 10 plus 5, which gives us 15. And you can see how we're getting the exact same terms we had in our original sequence, but we're doing it based on the previous terms. This is another way that we can define sequences, and I want to look at two examples of sequences defined recursively so we can get a little bit of experience here. Let's consider the sequence given by a sub 1 equals 2, and then a sub n equals 3 times the quantity a sub n minus 1 minus 1. This formula tells us to get a term, we take the term that came before it, subtract 1, and then multiply the result by 3. So we've got a sub 1, that's our starting term. To find a sub 2, we need to take a sub 1, subtract 1, and then multiply by 3. So here, 2 minus 1 is 1, and when we multiply that by 3, we get 3. It's basically 3 times 2 minus 1. Then to get the next term, a sub 3, we need to take the previous term, a sub 2, we need to subtract 1 and multiply by 3. 3 minus 1 is 2, and when we multiply that by 3, we get 6. Or using the formula directly, we've got 3 times 3 minus 1. To get a sub 4, again, we take the previous term, subtract 1, and multiply by 3. 6 minus 1 is 5, and when we multiply that by 3, we get 15. And we can continue doing this. If we subtract 1 from 15, that gives us 14. If we multiply it by 3, that gives us 42. If we subtract 1 from 42, that gives us 41. And when we multiply that by 3, that gives us 123. And we could continue over and over again to get more and more terms of this sequence. The last example I want to talk about is a very famous example, It is called the Fibonacci sequence. And it is possibly the most famous sequence in mathematics. So the Fibonacci sequence is defined by f sub 1 equals 1, f sub 2 equals 1, so the first two terms are both equal to 1, and then to find a subsequent term, f sub n, you need to add the two terms that came before it. So f sub n minus 1 plus f sub n minus 2. So if we look at the terms, we're told the first term is 1, the second term is 1, then we get the third term by adding the second and the first. So that gives us 1 plus 1, which gives us 2. And then we get the fourth term by adding the third and the second, so 2 plus 1 gives us 3. And we can continue doing this, adding the last two terms to get the next. 2 plus 3 is 5. 3 plus 5 gives us 8. 5 plus 8 gives us 13. 8 plus 13 gives us 21. 13 plus 21 is 34. 21 plus 34 is 55. 34 plus 55 is 89, and we could go on and on and on forever and ever. Now, the reason that this is one of the most famous sequences in mathematics is because it comes up in many different places in nature. For example, there are certain seashells that have geometry based on the terms of the Fibonacci sequence. Also, if you look at different types of flowers, most of them have a number of petals that comes from the Fibonacci sequence. There are a lot of flowers that have 3 petals, some have 5, some have 8 or 13 or 21, and there are even some types that have 55 or 89 petals. I'd like to encourage you to Google the Fibonacci sequence and examples in nature so that you can look at different examples yourself.